And Harshit, please turn on your camera. Turn on your camera. Mariam and Harshit, please turn on your camera. So if I'm talking about that, what are assets? What are assets? So assets are those substances that according to different scientists, like for example, Arrhenius said that according to Arrhenius said that assets are those substances that dissociate H plus ions in aqueous, that dissociate H plus ions in aqueous. When this means when they are added, okay, they produce H plus ions. Okay, got it? They produce H plus ions. Understood? And bases are those substance. Bases are those substance. When added to water, they produced OH negative ions. Okay, note it down, please. Harshit and Arya, turn on your camera, please.
So my camera has some problem since few days.
Sure.
Yeah, sir, and other classes also couldn't on it.
Okay. And you, Harshit, please turn on your camera.
Sir, same problem I'm facing.
Same problem.
The same problem I'm facing.
So should I talk to your parents? Can I send I transfer this message to your parents?
No, sir, just wait. I'm doing it.
What are you saying?
Sir, give me a minute, sir.
Okay.
So what is dissociate?
Aqueous, what do you say?
Dissociate.
Dissociate means breaking down. For example, this is HCl acid. When you add it to water, it will produce H plus ions and Cl minus ions. Okay. So it will break into its ions. That is called dissociation. Okay. Breaking down a compound into its ions is called dissociations. Okay. This definition was given by Arrhenius. Noted down. When you're done, please let me know.
Sir, I'm visible?
Yeah, you are visible.
Oops.
Sir, what is the name? The name of the person who said this?
What is the name? Arrhenius.
This one.
Arrhenius.
Arrhenius. Yes, sir.
Arrhenius. Arrhenius.
Okay, sir.
Okay. Done. The next scientist name was Bronsted Lowry.
Sir, can you show that?
Okay. Wait, Mariam.
Sorry.
Yes, sir, done.
Just a minute, let me. Okay, you done?
Yes, sir.
Okay. Now moving to the next part here is, I'm talking about the Bronsted Lowry concept. Okay, Bronsted Lowry. Next is Bronsted-Lowry concept. Next was Bronsted-Lowry. What does he said? Bronsted-Lowry. Bronsted-Lowry. What does he said? He said that acids are those substances. Acids are those substances Acid are those substances that dissociate or donate word is more appropriate. Okay, use donate word, that donate H plus ions in aqueous, and bases are those substances that accept the H plus ions, that accept the H plus ion in aqueous, that accept in aqueous. In aqueous means, what does you want? Word aqueous means?
In water.
Yeah. In aqueous. Done?
So for base year road that accept the H plus ions.
Yes, bases are those that accept the H plus ions. And that donate, he use only H plus ion, he did not say about the OH ion. So for example, if I'm having, let you add HCl to water. So it will add H3O positive plus Cl minus ion. What does it means? For example, if you have H positive, for example, if I'm talking about hydronium ion, H3O positive, okay? So how does this is called hydronium ion? Hydronium ions. Okay, it is called hydronium ions. And one thing you need to note it down, that hydronium ions does not means the H plus ion does not exist independently. H plus ions, note it down, H plus ions do not exist independently. H plus ions do not exist independently. Just a minute, let me plug in the charger. Yes, Mari. So what I'm saying that hydronium ion never exists independently. Is I'm audible to you?
Yes,
Yes.
sir.
Okay, it never exists independently. It never exists independently. Hydronium ion never exists independently. H plus ion never exists independently. It actually attached with the water molecule. This is the water molecule. Then it get attached with this water molecule and it form H3O positive ion. This is called hydronium ion. H3O positive ion. It is called hydronium ions. Okay. Understood?
Yes, sir.
Okay. Next. If I'm talking about this one, so here you see that this HCl is donating its H plus ion to water. So it is, and water is forming the H3O positive ion. So water is accepting the H plus ions. You check, water is accepting the H plus ion. So it is a base, and this HCl is donating its H plus ions. It has donated its H plus ions and forming Cl minus. It is forming Cl minus. So it is an acid. It is an acid. Okay, not a down C.
So, sir, what is the difference between the Arrhenius and Bronsted-Lowry's theory?
According to Bronsted-Lowry, he said only those acids are those which donate the H plus ions in aqueous and bases are those that accept the H plus ions. He does not bring the OH negative ion. But actually in Arrhenius concept, it was there that if you have NaOH, you add it to water in aqueous, when it is added to water, then it will become Na positive and OH minus ion. So according to him, it is a base because it is donating the OH negative ion. Okay, dissociating the OH negative ion, it is a base. It is according to Arrhenius concept. Arrhenius concept. But here you can check. Here you can check that according to Bronsted-Lowry, here water is acting act as a base because water is accepting the H plus ions. Okay. Like for example, if I take the next example like ammonia, NH3. Ammonia. Ammonia do not contain any H positive ion, sorry, OH negative ion. But when it added to water, when it is added to water, ammonia when it is added to water, it accept the H plus ions. It accept the H plus ions. Okay, like for example, NH3, when added to water, it is HOH and it form NH4 positive plus OH negative ions. Okay, so here water in water I'm writing like HOH. So it is accepting the H plus ion. It is accepting the H plus ions.
Okay, sir.
Okay, so and forming the NH4 positive ion. So here ammonia is act as a base, act as base, and here water is donating its H plus ion. So it is acting like an acid. Here it is act like an acid.
So can you explain it again?
Yes, why not? Sure, why not? For example, if I'm saying that NH3 is ammonia, and if it is added to water, H2O, it actually forms NH4 positive ion plus OH minus ion. It means this water has donated its H plus ion to it. That's why it is forming NH4 positive. So here ammonia is acting as a base. Ammonia is acting as a base because it accepts the H plus ion. It accepts the H plus ions from water. And here water is acting as an acid, acting as an acid because here H2O is donating its H plus ions. Do it.
Got it, sir.
Okay, note it down. Done. Noted. Now the question comes in examination that actually the properties of acids is shown by the H plus ions. Okay, H plus ions. If a substance is still having the H plus ions, the hydrogen, but when it is added to water, it is not donating the H plus ions. Okay, Mariam, you concentrate please. First, what I'm saying is stop writing. I'm saying here that, for example, if you add some substance, like for example, you add glucose. Okay, you add glucose. Okay, to water, glucose to water. You add glucose to water. Okay, on adding glucose to water, you notice that, okay, you notice that when we are adding glucose to water, it is not dissociating any H plus ions, but it is not producing any H plus ions. It remains in its original form, like C6H12O6. It is the formula of the glucose and it remains in its original form. It does not break. It does not give any H plus ion. So if, like similarly for ethanol, ethanol has C2H5OH, but it does not give OH negative ion, nor it give OH negative ion, like NaOH when added to water. It gives Na positive and OH minus ion. It do not give. It remain in its original form, C2H5OH. C2H5OH. It remain in its original form. So both glucose and ethanol are not characterized as acid. Why? Because when they are added to water, they do not dissociate any H plus ions or OH negative ion. So the property of acid is only shown when they are added to water and they produce the H plus ions. If they are not producing the H plus ion, they are not characterized as acid. Are you getting my point? So the condition for acid to show their property is to dissociate the H plus ions. Okay. Okay.
Yes, sir.
So note it down this question and answer. Wrote the answer here also. You done? Noted?
No, sir.
No, sir.
Noted fast.
Done, sir.
No, sir, 1 minute.
Done? Should I move further?
Yes, sir. It's only glucose and ethanol. There's nothing else.
Yeah, mostly. Any substance, if they are not dissociating their H plus ion, means they are not going to show their property.
Okay, sir.
Arya, you done?
Yes, sir.
Next, should I move forward? Mariam, you still writing?
Sir, done.
No, sir, yes, I'm done.
Okay. So similarly, if we take litmus paper, blue litmus paper is one that changes its color when added to acidic or basic medium. Okay. So if I took a dry HCl gas in a beaker, dry HCl gas. Okay, and if I took a blue litmus paper here, it is blue litmus paper. Okay. So according to rule that blue litmus paper change its color from blue to red in acid. Okay. So blue litmus paper changes color from blue to red in acid. Okay, means it changes to red when we are passing or adding acid to blue litmus paper. Okay, and dry HCl gas, HCl is an acid. So according to rule, it should change it to red color. But if it is dry blue litmus paper and it is dry HCl gas, when you are passing over it, it do not change its color. Can you guess why? Why it is not changing its color?
Because it's a gas.
Because of what? Because of HCl gas. So if it is HCl gas, so what? So what? If it is HCl gas, so what?
They're not connecting. They're not donating or joining.
So because there is no water content, dry HCl gas, dry blue litmus paper, no water. No water is present here. Okay. No water is present here. No water. No water content is present. No water content is present. And if there is no water content present, then what does it mean? It simply means that if there is no water, they simply say that there will be no dissociation of H plus ion will take place. And if there is no dissociation of H plus ions, no acidic property will be shown. Okay, no acidic property will be shown. So it is important for us or for acid to show their property, there must be dissociation of H plus ions. And water is going to help in the dissociation of H plus ion. It will not dissociate by its own. So if we pass dry HCl gas to dry litmus paper, no dissociation of H plus ion will take place. No, then no acidic property will be shown and no color change will be observed. But if you take this instead of this one, if you take moist, if you moist it, so when you moist it, this gas when comes in the contact with the moist blue litmus paper, it will change to red. Why? Because when HCl gas comes in the contact with the HCl gas when comes in the contact with the water that is present in the litmus paper, it will dissociate the H plus ions, and this H plus ion will help in turning the blue litmus to red. Okay, you getting my point? What I'm saying?
But sir, when litmus is in contact with water, doesn't that also react?
No. Water is neutral. It do not react with it.
Okay, sir.
So note it down the answer properly. Why do the color of litmus paper do not change to red when dry HCl gas is passed through it? And if the litmus paper is moist, then it change its color. Then it change its color. Note it down, please. Note the answer also.
So, sir, if any acid which is like in the form of gas, it will not change color.
What are you saying? Please pardon.
It's like if any acid is in the form of gas, it will not change color.
No, it will change its color because if it is not in gaseous form, it means that it is in aqueous. It might be in liquids in water. Instead of
No.
it is not in
When
water.
it is a gas.
Other acid, like if it is H2SO4 in gas.
Yeah. Will it change color?
Any acid if it is in gaseous form, it is passed through dry litmus paper, it will not change its color.
Okay.
Note it down fast. Noted? Yes or no? Noted?
Yes, sir.
Okay,
Yes, sir.
note this one also ki when when the moist litmus paper is taken, then the H plus ion dissociation take place as a result because of the moist present in the paper, water, because of water in moist paper, and hence the color of the litmus paper change. Note it down this one. You done?
Yes, sir.
Okay, let's move further. Now moving to the next part here is coming to this point here, we have a question that ammonia do not contain any OH negative ion. Ammonia do not contain any OH negative ion. Still, it is characterized as a base. Like you see ammonia. I have explained you here also that ammonia when added to water, ammonia is a gas. When it comes in the contact with water, it change blue litmus to red. It change blue litmus to red. Blue litmus to red. Oh, sorry, red litmus to blue. Red litmus to blue. Red litmus to blue. Litmus to blue. It change red litmus to blue, indicating it is a base. Indicating it is a base. Is a base, indicating it is a base. And if for sure if it is a base, then it does not contain like sodium hydroxide is a base, magnesium hydroxide is a base, calcium hydroxide is a base. So it does not contain any. Okay, so why it is changing its color? So simple, because it accept the H plus ions from water and form ammonium ion that I have explained you there and OH negative ion. Okay, so we'll say that since it is accepting the H plus ions from the water, which show the acidic property, it is accepting. So the concentration of OH ion will increase. Concentration of OH ion will increase. OH ion concentration will increase. That's why I'll say that it will change. It's okay. So note it down, please. Note it down that ammonia do not contain any OH negative ion. Still, it is characterized as base. Note it down. Done. Ammonia do not contain any OH negative ion. Harshit, are you writing? You have turned off your camera.
Yes, sir, I'm writing it.
Turn on your camera, please. Yesterday it is characterized as base in water because you will write that ammonia when added to water, it accepts the H plus ions. It accepts the H plus ions from water and thereby increase the concentration of OH negative ion. Okay, in the solution, and thus the solution become basic in nature. And thus the solution become basic in nature.
So there is orange litmus, right?
What are you saying?
Orange litmus paper.
No, orange litmus paper is not here. Only blue and red.
Oh,
So why is it H minus OH?
NH4 positive plus OH negative. Yeah, it will be NH4,
Okay.
ammonium hydroxide. Together it form ammonium hydroxide, NH4OH. Okay, note it down.
Done so.
Okay. Let's move further. Now we shall be moving towards the acid base. Have you, Mariam and Arjit, have you noted that one? Nabila, Arya, the previous one?
yes, sir.
Or Mariam, you were doing it still? I know, I come to your face. So note it down, please. That's why camera is good. So if you turn on your camera, it means that we can notice the student is writing or not writing.
Sir,
Yes.
do you see this?
Yeah, I can see you this. I can see.
So we did this in the chemistry lab, and this is litmus paper, and it's yellow or orange.
When you add it to something, like it can be red
No,
paper, or it is a pure.
yeah, it's no, it's with water, like tap water.
You add it to tap water, na?
Yeah,
So it might have some acidic minerals also there. So it might change its color.
but then this is like when they showed it to
When
us,
you
it
when
was
you when you bring it from the lab, was it yellow?
it was the same color.
Same color.
Yeah.
So it might be.
Okay.
It might
Yes,
be
sir,
possible
done.
that in Saudi Arabia or in Riyadh, because of hotness, the purple color or the red color litmus paper become yellow. It is not actually red. It is not. It is like orange. It's not like red. Red means the red like you see your mic, unmuted mic color. It is not like that. It is just like orange, not exactly red, not exactly yellow. It is in between. Okay.
Okay, sir.
Done.
Yes, sir.
So let's move further. Now we shall be moving towards the acid-base indicators. What are acid-base indicators? Acid-base indicators are those indicators that changes their colors when added to acidic or basic medium. Those indicators that change their colors when they are adding either color or smell. Either color or smell. Order means smell. Okay. So is there any substance that is changing its color or order or smell when added to acidic or basic medium? We called it acid-base indicators. Okay. Got it? Are you there? You understood?
Yes, sir.
Yes, sir.
Okay, so please do this one. Those substances that change their color, order, or smell when related to acidic or basic mediums are called acid-base indicators. Are called acid-base indicators. Write their colors with the examples. Right up to here, please.
So till when do you think we'll be able to finish this chapter?
Till Wednesday. What do you say?
Pardon?
Till
Till when do you
when?
think we'll be able? Till when do you think we'll be able to finish this chapter?
It will take the whole month of May, as well as it might be half month of June. It require 1 month. 4 to 5
Oh,
classes,
okay.
more than 5 to 5, 4 to 5. We have 1 chemistry class in a week. And accordingly, in a month, we have 4 classes. And we need 5 classes, 5 to 6 classes to complete this chapter. So it will take the whole month in July. Means in the first week of July, it will be completed. When your school will be open, it will be completed.
Sir, we have exam on June 3.
And in that the acid, base and salt is coming.
Yes, sir. The first and the second chapter, chemical equations and acid base and salt.
How I don't think that how your schools is going this mismanagement.
For me
Whole
also
year.
the
We
same.
have the whole year. This
For
school
me
started
also
in
the
the
same.
May and June. In a 2 month, they have completed 2 chapters. How it is possible? How they are able to complete means you have 1 class of chemistry, you have 1 class of physics and 1 class of. Do you have every day one classes of each?
And
1 class of
almost
physics.
sir, in a week, we have 2 classes of
every day,
chemistry,
sir.
physics, and bio.
You have 2 classes. In a week, you have 2 classes of science.
So
Na?
we have 3. Yes, sir.
So
So
I
we
also
have
have
3
extra
classes.
classes on Saturdays.
For every week, you have 2 classes of chemistry.
No, sir, 3 classes for me.
And Nabila,
3
you
classes for me.
3 classes.
for
Sir,
chemistry
we have 2.
Yes,
Yeah,
sir.
in a week.
Yeah.
Sir, in my school, I have school till 4 o'clock. That's why they can complete more portion.
So
Also my science exam is on 10th, and acid bases and salt is coming, but universal indicator and pH in everyday life is not there, but the rest of the whole chapter is there, and the first chapter.
don't know, we have 4 chapters in total chemistry, and if we are just going to finish the whole in the first in June, then what we are going to study in the rest of the year?
So they want to
Accordingly,
complete
they
portions.
will be going to complete the whole syllabus in August. Then what you are going to do in the September, October, November, December, January, and Feb?
Exams.
Sir, there will be summer break. So that after
Yeah.
that, they will do the other 2 chapters.
Summer break.
So my school said that they will complete by October, like the latest.
The whole syllabus in October.
By October, the latest. Yes. Because we have models.
We'll talk to the team. Okay, don't worry. We'll talk to the team about your conditions. Okay, have you noted this one? Till here, note it down. Till this, please note it down. We'll talk to the team about your issue.
So in my school, they'll complete the syllabus till November.
When they have completed this, have they completed acid bases and salts in your school?
No, sir. It's like
Yes, sir.
they have started.
No. Aisha, when did you come?
So where?
When did you join?
I have joined at 5:15.
5:15. Why you joined so late?
Sir, actually, I was having another class.
Okay. Okay. So do this one, please. How do acid base indicator works? Okay. So have you noted this one? Then we shall be going to, don't write this one, how do acid base indicator works. We're going to discuss this one in some other class. Note it down, please.
Done so.
Okay, let's move to some questions here. Okay. So if I'm saying that here, if I'm talking about this acid base indicators, you know that acids are those substances that changes their color when they are added to acidic or basic medium. Okay. There are some more examples. Let you concentrate here. That there are some olfactory indicator that changes their smell when they are added to acidic or basic medium. So when some substances are changing their smell when they are added to acidic or basic medium, it simply means that they are changing their smell. Smell means there are some substances because when they are added to acidic or basic medium, they are changing their smell. So that's why they are considered to be as olfactory indicators. And if a person is visually impaired, means he cannot see things. So how can he be able to distinguish whether if we are having red litmus paper or blue litmus paper, and if the HCl gas is passed through it or anything, because he cannot see anything. So how can he change? How can he identify whether substance is acidic or basic by seeing the change in color? So how can he smell? It means how can he identify whether something is acidic or basic? So with the help, he can identify with the help of olfactory indicators. Olfactory indicators. So like for example, vanilla essence, onion, cloves, they change their smell. So he added when clove is added or onion or vanilla essence is added to some acidic or basic medium, they have different smell in them. So we can recognize whether it is an acidic substance or a basic substance. So please note it down the definition for the acid base indicators, olfactory indicators.
So these olfactory indicators, like, do they have their own distinct smell though before adding an acid or a base?
Yeah. No. Before adding, no. They might have their particular smell like clove also have, but when they are added to acidic or basic medium, they change their smell. Okay. They change their smell. So
Okay,
that's
so
why. So note it down, olfactory indicators.
So only that one.
Yeah. Then after note down the natural indicators also. Note down the natural indicators also.
Sir, can I leave? I have test.
What are you saying? Can I?
Leave. The team is calling for the test.
Okay. Just a minute. Complete it done up to here. Natural indicators.
No, sir.
Note it down.
So if you're done, we can leave.
Yes, you can please.
Thank you, sir. Bye. Take care.
done so. Thank you, sir. Bye.
Bye bye. Take care.
Yes.
Done, Mariam?
Yes, sir. Bye, sir. Thank you.
Right, take care. Okay. So yes, Aram, Bharti, how are you? Is audible to you?
Yes, I'm fine. Alhamdulillah. How are you?
Okay. So just a minute, let it 1 or 2 minutes so that your student may also join. Okay. Just wait for 1 or 2 minutes. You done? Sorry. Heather, yes, is I'm audible to everyone? Aram, Bharti, Heather, and Samia. And Anam, how are
Yes,
you?
you are.
Okay. So let's move further. Okay, today we shall be going to start. Should we start the next chapter or we have done the latent heat in the previous classes? Na? We are discussing the latent heat. Okay. And latent heat of vaporization we were discussing. Okay, so let's move to the next part today. Just a minute. Just give me a second, okay? The screen is visible to you.
Yes, sir.
If the questions comes in examination, why do the temperature do not increase when ice changes into liquids? Okay, still we are just keeping the temperature. We are just applying the heat. Why do the temperature do not sorry? Why do the temperature do not rises? So what you will going to try? How will you answer this question? How will you be able to answer this question? Tell me, note it down fast and try to write it in your own words, please. And everybody is requested to turn on your camera. Everybody is requested to turn on your camera, please. Anam, Bharti, Heather. Please turn on your camera. So you done? Why do the temperature do not change? Anam, turn on your camera, please. Hanan, Furkan. Furkan, please unmute your mic. Hanan, is I'm audible to you? Anam, is I'm audible to you?
Yes, sir.
Anam and Bharti, is I'm audible? Furkan. So if I'm audible to you, so I'm saying you to please turn on your camera. Okay? Is it audible to you? What I'm saying? Okay, let it be. I'm not going to teach further if you are not going to turn on your camera. I want everybody to turn on your camera. Otherwise, I'm not going to teach any further. And please don't waste the time for the other student because some of the students have turned on their camera and they are waiting for you to turn on your camera so that the class may go further. So I will not teach anybody if you're not going to turn on your camera. If you are having problem with the face, please go and have a mask on your face because there should be an eye contact between the teacher and the students so that we can understand whether you are getting the things or not, whether you're looking to the screen or you're looking somewhere else when I'm teaching to you. So Furkan, Heather, Hanan, and Anam, you have not turned on your camera. It is requested to please turn on your camera. Please unmute your mic. Heather, please unmute your mic and let me call to your parents so that you can let's check what problem you are going to have. Let's identify. So sir, yeah, let's just wait a minute. Let me check whether the Mohammed Heather is not going to turn on his camera. And please, are you turning on? Yes, he's turning on. And Furkan, are you turning on your camera or should I call you to call the team to talk to your parents? Are you turning on your camera? Furkan, you there in the class? And Saad? Saad, are you turning on your camera?
Yes, sir. Give me.
Turn it on. And Mohammed Saad, please turn on your camera. Otherwise, we are going to call to your parents. Okay. There should be an eye contact between the teacher and the students, okay? Because when we teach something, if the student is looking somewhere like this, so what I will do? I will simply say, don't look at there, please concentrate on the screen. So this is important for everyone, please to turn on your camera so that we can understand whether you are getting something or not. Okay? Otherwise, how will you get the good marks? You might be doing like this. Okay. Saad, your video is not coming. Still. And Heather, what you done in your hand? You got fractured? Okay, it's okay for you. If you are getting you have fracture in your hand, it's okay. It's okay. You can have your phone nearer to you. It's okay. It's not necessary to show you. Whenever I ask you whether you are writing or not, show me with the camera. Okay, go ahead. I'm just reliable for you. If you are having circumstances, if you are having fractured in your hand, plaster in your hand, it's okay. It's okay, beta. We are compatible with the student. If you're having some problem, it's okay. But genuinely, you need to study properly. So let's start. In the previous class, we were discussing about some questions. And here we were just discussing that the temperature remain constant. Temperature do not change when an object is, okay, it's changing its state. Okay. Why do the temperature remain constant? I have explained it many times. Okay. That whenever we are changing the state of matter, the heat that we are supplying, it goes in overcoming the force of attraction between the particles